I'm Jakob, and I'm working on the charter project now with Signe Normand and Marc Macias Fauria in Oxford, and Signe is at Århus in Denmark. And I have been sort of really interested, right, kind of sort of from the early stages of my scientific education in facets of like spatial ecology. So there's this whole like kind of component of ecology where we're trying to understand how things relate to each other in space. And with that, I mean like the physical space. So if you think about a landscape, you have both the two-dimensional space, so that's like kind of the map, classic sort of like surface that we're looking at from a geographic perspective. And of course, now these days, we're also starting to get much more at like three-dimensional components of space. So that being like vegetation structure and all these sort of things. But yeah, it just happened then that during my PhD, I met a PI working at the University of Edinburgh. She's called Maya Smith, and she's a very famous shrub researcher. She's been sort of involved in the greening of the Arctic. So we have this incredible increase, and it's not a good incredible, it's a sad incredible increase of temperatures in the Arctic region, which is where temperatures are rising twice as fast as sort of the global average. And we're now already in 2020 experiencing conditions for 1.5 to 2 degrees warmer in the Arctic. And this has got huge implications for everyone who lives there, including the plants, the animals, and the people. And it's changing the landscape, both in sort of the physical aspects. So we've got erosion, permafrost erosion, glaciers melting, things that you kind of like hear about in the news, but also in the aspect of the plants. There's a lot more energy available, it's warmer, the plants love that, they grow more. And what we're trying to figure out, I think sort of in the overarching project that I've been working in most of the time, and sort of the research questions where my spatial ecology interest really like comes out is we're trying to understand how the change in the plants, how this increased growth and the mixture is affecting the ecosystem as a whole. So how is it affecting the carbon cycling? How is it affecting the herbivores that use it? And how is it affecting the physical aspects of the landscape? So if you think about the albedo that's familiar to many from the ice feedback, so like brighter surfaces, they send light and heat back into space. But if you now suddenly have a lot more tall plants that grow above the snowy surface, then it's not white in wintertime anymore, but dark, and it absorbs heat. So there's a lot of interesting stuff going on. And from an ecological perspective, even though the implications are sort of quite harrowing, potentially harrowing from a sort of like climate perspective, from an ecological perspective, it can be very interesting. And I just started my PhD when drones were coming into the field. And so for spatial ecology, like a drone is the perfect tool. We're like talking about a system where plant growth happens on centimeter scale. So these Arctic, we talk about shrubs, we're talking about, in some places, about plants that grow not taller than your ankle. So if you want to measure that with satellites from space, the resolution of the sensors and cameras that are on the satellites is just not good enough. So with the drones emerging, we are really kind of entering sort of a new era in geography or in plant spatial ecology, where we can now map things that are kind of happening at the scale that the plants are growing. We're still working out what exactly the details are for the fieldwork with Charter and how I might be involved in this, but I think the real potential is, even though we don't have the long-term time series from the drones yet, the real potential is to understand the current state of the system and then allow us to better interpret the satellite imagery at the moment, so that we can then understand what the time series from the satellites that we have in the past might mean actually. So if we are, for example, seeing a trend change in a satellite pixel that is 30 times 30 meters, for now, we can only like kind of muse what that might be, what might be causing the changes. But now with the drones, we can sort of start comparing satellite pixels now at the current state from one to the other, and even get shorter term time series over multiple years. And we can start to figure out what changes in those satellite pixels actually relate to in the real world using the drone. So if we see like, oh, this pixel is greening, and if we look at it with high resolution data from the drones, we can see, oh, maybe over the last 5 years, it has been greening, and we have seen this plant composition change with the drones, or for example, we've seen a landslide there and suddenly the pixel got browner, but we couldn't really pick that up with the coarse resolution that the satellites have to a degree that is meaningful in these sort of like very small growth systems. We're currently planning maybe to go to Siberia, to Yamal, where Bruce has been working a lot. And then we are hoping that we could maybe study the impacts of the enclosures that have already been set up there. So the idea is sort of studying the interactions between the herbivores. In this case, it's caribou or reindeer, and the plant and the vegetation. So what happens if you fence off a bit of the landscape, and how does it change the whole dynamics in the system? How do the plants respond, and how do the herbivores also respond if you give them different opportunities to forage, you know? Yeah, so but that's all up in the air. But I think one thing that I should say, that sort of most of the stuff that we have planned already will be quite sort of data driven. Right. So aside from being interested in sort of the drone and spatial ecology side of things, I'm actually also sort of, I think what I sort of really bring into this project is that I'm quite an I had this knack for programming when I was a teenager, and that comes now really handy when being an ecologist. So we really like kind of gonna harness some of that sort of knowledge that I have, that we're bringing in terms of data handling, data analysis, creating databases where we fuse both sort of spatial data as well as paleoecological data and contemporary ecology data, to create this long-term perspective and comprehensive perspective, both in space as well as in time, that we need to fully understand the long-term changes that can happen in systems, and then therefore predict what might happen in a much better way than what we can do at the moment. So